Let's move on to the next question. So relating to a point O, the position vectors of A and B given to you by this. So pretty cool. We know that OA is the same thing as 2, 3, minus 1. And OB is the same thing as 4, minus 3, 2. Part 1. We have to use scalar product to find the angle AOB, correct, to the nearest degree. So now again from O, we can go to A or go into B. So you have to be OA times OB should be magnitude of OA, magnitude of OB, and then cos of the angle AOB. So here we have the two vectors over here for scalar product. Now OA is 2, 3, minus 1. OB is 4, minus 3, 2. Now the length of OA is root of 2 square plus 3 square plus 1 square. That should be 14. And this one should be 16 plus 9 plus 4. That should be 29. Cos of the angle. Now simplify this. 8 minus 9 minus 2. That should be minus 3. Divided by 14 times 29 should be root of 406. That will be cos of the angle O. From this, we can find the value of the angle AOB, sorry, that will be cos inverse of this. Let's see what do we have. So minus 3 divided by root of answer should be this. Cos inverse of that should be, so here we have to use degrees. So cos inverse of minus 3 divided by root 406. That should be 98.56, which is 99 degrees. Correct to the nearest degree. That is part 1 of the question. Now for part 2, we have to find the unit vector in the direction of AB. So first thing first, we have to find AB. AB is defined by OB minus OA. Again, always we have to look at the second one first. So AB will be OB minus OA. Now from this, OB will be 4 minus 3, 2. OA is 2, 3, minus 1. So that will give you what? 4 minus 2 is 2. Minus 3 is minus 6. That should be 3. Right. Now unit vector we have to divide by the magnitude. So what is the magnitude of AB? That should be root of 4 plus 36 plus 9. We have to square those values. 4, 36, and 9. So 4 plus 36 plus 9, it should be 49. And that is 7. So the unit vector in the direction of AB will be AB is 2i minus 6j plus 3k divided by 7. That should be the unit vector in direction of AB. Now for part 3, the point C is such that we have OC is this, where P we don't know, right? Given the length of AB and AC are equal, find the possible values of P. Now the length of AB, as we have seen here, it is 7. Now we also know the length of AC have to be 7 as well, according to the question. Now how would you find this? By definition, AC have to be OC, again take the second one first, minus OA. OC given to you by 0, 6, P, minus OA given to you by 2, 3, minus 1. That should be minus 2, 3, and P plus 1. Now to find the length, we have to use the formula we know, that is 4 plus 9 plus P plus 1 square. Have to be 7. Same length as AB. Square both sides, you will have 13 plus this. Have to be 49. So P plus 1 square have to be 49 minus 13. That should be 36. Which means P plus 1 have to be plus minus 6. Now from this, P has to equal to minus 1 plus minus 6. So P can be minus 1 plus 6. Or P can be minus 1 minus 6. That could be 5 or could be minus 7. So these two are the possible values of P for when their length are equal. Now this one was a question in relation to vectors, and that was the last question of this paper. Thank you for watching. I will see you soon.